This is cycle 1, lesson 0. This is review material from grade 11. We're just going to review some of the terms and ideas from the grade 11 course that are going to be helpful to us in the advanced functions course. So this lesson is really just sort of not one specific topic, but a variety of different things. So we're going to start off with domain and range. Domain is the set of all possible input values. X values is the way to think about it. Range is the set of all possible Y values of a relation. Remember, a relation can be represented various ways. It can be represented as an equation. We most often use X and Y as our two variables, but you have to have two variables to have a relation, or two or more. The reason why it's called a relation is because how does one variable relate or change compared to another one? All right, so we, by convention, call the X values our input. We call the Y values our output. And so you just have to wrap your head around the idea that domain is all your X values. Range is all your Y values. So to illustrate that, I've got a couple of examples. Let's look at this one first. So up at the top, you see an equation, y equals negative bracket x minus 1 bracket squared plus 3. Hopefully you recognize that as a quadratic. It's got its vertex at positive 1, positive 3. The negative sign out front means it's going to open downward. So we've got the graph. If you look at the graph, now we want to think about domain and range. So the domain, again, is all possible X values. So we want to focus on just going from side to side with this one. So going from side to side, not worrying about how high or low the graph is. What's possible? Well, everything's possible. So I could go start at negative infinity. There's arrows at the bottom of these graphs here, right? This is an arrow down here on the left and an arrow down here on the right. So it's going to keep going on forever, and it's going to keep going out to the left forever. It's going to keep going out to the right forever on the right-hand arm. All X values can be represented in this graph. Now, another way of thinking about it is I can't think of any X value that won't have a Y value, a point on this graph. And so if all X values are possible, the easiest way to say that is just to say that X is a member of the set of real numbers. That's what this is saying. Remember this weird terminology. Those squiggly brackets just mean the set of. And then it's saying X. This here means is a member of. That thing that looks sort of like an E, it means it's a member of. And then this R with the two upright sticks represents real numbers. So real numbers, remember, are decimals, whole numbers, natural numbers. We'll review that in a second, but it's all these different numbers. Basically every number we can think of, that's real numbers. So really, all this is saying is that the domain is any X value you can think of. As for the Y values, that's the range, right? So the range, what Y values are possible for this particular function. Well, as you can see, the highest point is at 1, 3, and all the points below that will be represented. There's Y values for anything below that, but there's no Y values that go but higher than 3. So that means the range, again, being the Y values, is all the real numbers, again, as long as they are less than or equal to 3. So that's how we read that. Okay, so domain is X, range is Y. Here's one more example. This one, here's the equation over here. Y equals the square root of X. And hopefully you remember that. That is a radical function. It's like a part of a sideways parabola. And this is the graph of it. You can see on the screen here. It starts at the origin, it goes upwards and towards the right, and that arrow shows it keeps going forever. So just looking at the graph, what X values are possible? That'll be our domain. Well, it starts at the origin, and it goes to the right. So if it goes to the right, it's only going to be positive numbers. But it's all possible numbers. So how do I say all possible numbers? Well, again, I say it's all real numbers, but think of this as a restriction at the end, only the ones that are greater than or equal to 0. Okay, the range, what's the y values? Well, again, we're only focused on what's up and down here, right? So again, we're starting at the point 0, 0. We're starting at the origin. I'm focused on this to start with. And it only goes up from that origin. So it's all the real numbers, again, but then there's a restriction, as long as they're greater than or equal to 0. Okay, so that's domain and range. Remember, here's a quick review of number sets. This is grade 9, but it's good to review these things. Natural numbers start at 1 and go up without decimals, 1, 2, 3. Whole numbers start or include natural numbers, but they also include the number 0. So very little difference between those two. Integer numbers, we're still not dealing with decimals, but now we can include negative numbers as well, so like -3, -2, and so on down to -infinity. Rational numbers are ones that can be written as a fraction. That's the test. Can you write it as a fraction? So it includes the natural numbers, it includes the whole numbers and integers, because we can write, for example, we could write -2 as a fraction in many different ways. But it also includes things that have decimals, like 4.12 or 0.3 repeating. The way we know if it can be written as a fraction is if it's a decimal, if the decimal either ends or it repeats. So 4.12 I could write as 412 over 1,000. Or 0.3 repeating I could write as 1/3. So if I can write it as a fraction, it's a rational number. Irrational numbers are just ones that can't be written as fractions. Those would be decimals that neither end nor repeat. And pi, which is what you can see here, 3.1415, is a famous example of that, but there are lots of others. Real numbers are just, if you take rational and irrational numbers together, that pretty much covers everything, and that is your real numbers. That's the one that we represent with the R, the funny R like that. So set notation can be used to describe domain and range. Again, talked a bit about that already. We have the squiggly brackets. We have the set of numbers that we're using, like x is a member of R. And then we just have to pay attention to which direction the greater than or less than signs are going. If we read it from left to right, what we can see here, the one that says 0 is less than x, which is less than or equal to 50. So if we're reading it from the left, then the alligator mouth is always pointing towards the bigger thing. So if I'm starting with 0, 0 is less than x. There's no line underneath it, so it's not or equal to, it's just less than. And the one that does have the line underneath it, x is less than or equal to 50. Notice how, in the way it's written though, it says that x is greater than 0. So I read it as 0 is less than x, but it's been turned around in the text here, the way it's written, as x is greater than 0. Obviously, if 0 is less than x, then x is greater than 0 means the same thing. It just depends on how you're reading it. I was reading it from left to right. The way it's printed out here is reading it focusing on the x. A function is a relation in which each element of the domain corresponds to exactly one element in the range. So we just reviewed domain and range. So let's just wrap our head around that. An x value cannot have two different y values. Easiest to visualize it on a graph. So, for example, this is a relation. You'd recognize it. It's a circle. Pick any point, any x value, or pick any x value here. All right, so let's pick the one where I've already got the line drawn. So let's pretend for a second that x value is the x value 4, okay? Well, that x value 4 has got a y value going along with it that appears to be about -4 as well, right? So it would have the point 4, -4. But it has another one up here. We would have 4 and, I'm just estimating here, maybe that is 12. So that one x value of 4 has got 2 different y values associated with it. That's what makes it not a function. We can tell it visually by, if we just draw a vertical line, if it touches the graph in 2 or more places, then that just visually lets us know there's going to be 2 or more y values associated with the x value, and it's not a function. So that's a quick way of doing it, the vertical line test. So a relation is not a function if you can draw a vertical line through 2 or more points of the graph. Graphing note. Okay, closed dot at the end of a line segment means that the endpoint is not included. An open dot at the end of a line segment means that the endpoint is included. So again, here's a picture. This one here on the left, I've got an open dot. That means if that was the point -4, -2, this function would get very, very close to -4, -2, but it never actually includes that one. Whereas this one here on the right, being a closed dot, 5, 3, means that the function gets closer and closer and actually does include that point 5, 3. So here are some examples. State the domain and range in each case. Okay? If it's given to you as an equation that you can easily visualize, like y equals x squared, I hope you can visualize that. I've sketched it here at the bottom. It's a parabola opening up. Then that's a good way to get the domain and range. The domain for any parabola is all real numbers. The range for this one, because the vertex is 0, 0, and it opens up, I know that it's all real numbers. Y is going to be all real numbers that are greater than or equal to 0. It's going to include the 0. If it's given as a set of points, such as 1, 1, 3, 2, 5, 1, the domain is all the x values. We've got to keep in mind that idea that domain is x, range is y. I've highlighted all the x values in yellow, and so the domain is just the x values, 1, 3, 5. The range is all the y values, 1, 2, 1, but I don't need to repeat that 1. That's why it just says range is 1, 2. Okay? For the next one, this is a mapping notation. We talk a little bit about it, I think, in grade 11, and we talk a little bit about it in grade 12. It's just a different way of showing how points go. So think of the x, where the arrows are coming from are our input, our x values, and where the arrows go to are our output, our y values. So we can think of these as ordered pairs. So we got the ordered pair 1, 15, right? We've got the ordered pair, whoops, jumped around on me. We've got the ordered pair 2, 15. We've got the ordered pair 2, 30, because there's 2 arrows coming out of the 2 going to different y values. And so the x, the input is the domain again, and so it's 1, 2, 3, 4. The range is 15, 20, 30. Notice how 25 is not part of the range because it's not really actually associated with any points. Yes, it's there on the picture, but it's not, there's no arrow coming to it, so 25 is not part of the range. For each part of example 1, state whether or not the relation is a function and why. Well, the first one is a function. The easiest way to tell for a part, again, I'm going back to this and just deciding whether or not that's a function. That's a function because it would pass the vertical line test, right? We can see that right there. B part is a function because there's no repeating of the x. Remember, we can only have one y value for each x. So as long as each x value is distinct, like 1, 3, 5, I never have 1 show up twice or 2, 3 show up twice, then I can't be repeating the x. And if I was to graph it, as you can see I've done, it would pass the vertical line test. So this is my graphing of it here. It's just these 3 points, and they pass the vertical line test. Sorry for my screen jumping around. Every time I undo something, it seems to jump on me. I hope that's not too disorienting. As I said, for C part, think of these like ordered pairs. This is not a function, and it's because of what I was talking about before. If you look at the number 2 on the left, there's 2 arrows coming out of it, meaning that there's 2 outputs for a single input. So, not a function. For each relation, state the domain, state whether the relation is a function for number 3. We got a series of points. And so I just think of them as ordered pairs. I just list all the x values. I listed all the y values. All the x values are my domain. All the y values are my range. This is a function. It would pass the vertical line test. For B part, again, it's a parabola. The domain is all real numbers. The range is all real numbers that are less than or equal to 3 because that's the y value of the vertex. The vertex is at 1, 3, and it goes down from there. So y value range is all y values less than or equal to 3. Passes the vertical line test, it's a function. For C part, we got what's called a piecewise function. We got 2 separate chunks, but it's one graph or piecewise relation anyway. So the domain is, again, what x values are we looking at? So if we look at this, and we go from left to right, I find this easiest to read it this way. If I start here at -5, and I go over, and it's all the x values up to here, and then it jumps down to here, but let's just keep going, actually. Let me do it here. Let me do it on the x-axis. We're starting at 5 here on the x-axis, and we're going along, and when we get to 5, then yes, it goes from one piece to another piece, but there's really no gap in between. All the x's are picked up all the way up until you get to about here, which looks like, what, 11, maybe? It's hard to read on this grid. But all the x values are represented between -5 and 11. As you can see, I've drawn this line on the x-axis that shows that. As far as whether I use a less than sign or a less than or equal to sign, for this in here, notice how I did not put an equal sign underneath. It's because this is an open circle here at -5. So -5 is not included. That's why there's no equal sign included there. Whereas we have a closed circle here at 11. That's why this equal sign was included in the greater than or less than. The range, now we're just focused on the y values. Even though there's a whole infinite set of points involved here, they all have one of 2 y values. They only have the y value of 2. All these points on this line have a y value of 2. All the points on this line segment have a y value of 6. So the range is just those 2 values. And it is a function. It passes the vertical line test. Yes, a vertical line goes through here, but remember, the bottom line segment is an open circle, so it's not actually including that point there. So it does pass the vertical line test. The last one's a circle. The domain goes from -5 to +5, and it includes those values. The range goes from -5 to +5, and it includes those values, so we have the or equal to in each case. And it's not a function because it clearly fails the vertical line test. State whether each graph shows a function or not. So now all we're really checking is, does it pass the vertical line test? This one fails the vertical line test. This one fails the vertical line test at so many points. This one passes the vertical line test, again because of that open circle at the top. Determine the domain and range of each function. Well, this one, all we were given was an equation. So hopefully we recognize right away that it's linear, slope y-intercept form. Any straight line is going to be a function unless it's vertical. But as far as the domain and range go, again, because it's a line, it goes on forever in all directions. There's no x values that it couldn't be. There's no y values that we wouldn't eventually get to if we make the graph go on far enough. So the domain is all real numbers. The range is all real numbers. For this one, the quadratic, easiest to go do the domain and range if you sketch the graph. So I've got it off the screen right now. Let's just visualize it. The vertex, what's that? -1, +6. The direction of opening, down. So can you see it? Vertex -1, +6, and a direction of opening down. -1, +6, opening down, something like that. Well, the domain is all real numbers. The range is all real numbers that are less than or equal to 6, the highest point, and there you have it. The last one, you might have a little trouble visualizing this one. So I'd say in this case, draw the graph, go to Desmos. Remember we reviewed that? So Desmos, we go square root of 2 minus x. There's various ways of doing it, but I think that this is the quickest for us. Y equals square root 2 minus x. Okay, this is what the graph looks like. What is the domain? This goes on forever, right, to the left. So it goes as far as -infinity on the left, and it comes up to +2 on the right. That would be our domain. So anything less than +2, less than or equal to +2, that's our domain. As far as our range goes, the y values is on the x-axis, so the y value here is 0, and it's anything above that. So the range is anything greater than or equal to 0. And the rest of this is just me playing around with it, so I wouldn't worry about that. I think let's just stick with what I did on Desmos. And that's it.